It's a quiet night, the kind where the stars seem to sparkle just a little brighter. You find yourself standing by a window, gazing up into the vastness of the sky. The darkness above is endless, a black canvas dotted with countless stars, each one a distant beacon of light, a reminder of the vastness of the universe. As you watch, something unusual catches your eye. One of the stars doesn't seem to fit. It flickers, it pulses. At first, you think it's just your imagination, but no, this star is behaving differently. It isn't like the others. Its light is not steady. It grows brighter, then dims, as though it's alive, breathing with a rhythm all its own. You blink, unsure if you're seeing things, but there it is again, a flash, a flicker, then a soft glow fading into the dark. Why is this star behaving so strangely? What could cause such a pattern of light? Is it a sign of something far beyond our understanding? You wonder, could this be a glimpse into something greater, something hidden in the infinite expanse of space? The object in the sky, as mysterious as it seems, is not just any star. It's a pulsar, a neutron star, in fact, one of the most fascinating and enigmatic objects in the universe. But this particular pulsar is no ordinary one. Most pulsars, you see, follow a regular pattern. They rotate rapidly, sending beams of radiation across the cosmos, creating flashes of light that we can observe as they sweep past us. It's like a cosmic lighthouse, constantly turning, giving us glimpses of their intense energy. But this pulsar, the one you're watching now, does not obey the usual rules. Neutron stars are born from the remnants of massive stars that have exhausted their fuel and collapsed under their own gravity. These stars are incredibly dense, so much so that a single teaspoon of their material would weigh as much as all of humanity combined. But the true intrigue lies in their magnetic fields and the intense radiation they emit. When a pulsar spins, the beams of radiation sweep across space like a spotlight, but they do so with perfect precision. Or, at least, they're supposed to. Yet, this pulsar in the sky is different. Its pulses aren't regular. The light flickers erratically, growing brighter and dimmer in a way that doesn't make sense. It's as if it's trying to tell us something. Something is off about this star. It doesn't fit with the normal behavior we've come to expect from these strange objects. So, what exactly is happening here? Why does this pulsar behave so unpredictably? What could cause it to act this way? It's a question that scientists have been trying to answer for years. And yet, the more they study, the more questions seem to arise. Some scientists have hypothesized that these strange pulsars could be interacting with other objects in space in a way that we don't fully understand. Perhaps the pulsar is being affected by a powerful magnetic field, something far stronger than we've ever seen. Or maybe there's something going on with its surroundings, something we can't yet observe. The universe, after all, is full of hidden forces, many of which we haven't even begun to comprehend. But there's another theory, a much more daring one. What if these odd pulsars aren't just anomalous by accident? What if they are part of a greater cosmic mystery? What if they are trying to tell us something about the very nature of space itself? These pulsars might hold clues to understanding the deeper forces at work in the universe, forces that could help us unlock the secrets of space time itself. What if, just maybe, they're not just pulsars? What if there's something much more exotic, something we haven't even begun to imagine? Perhaps these objects are a bridge to something far beyond our current understanding of the cosmos. Perhaps they are the key to unlocking mysteries about gravity, space, and time. And what if, one day, we discover that these pulsars are connected to something far greater, something that could change the way we view the universe forever? As you watch this flickering star in the sky, you can't help but feel a sense of wonder. It's as if the universe is quietly whispering to you, inviting you to look deeper, to question everything we know about the cosmos. There's a mystery here, something we're only beginning to understand. And as you stare into the vastness of the night, you can't help but wonder, what else is out there waiting for us to find it? This mysterious star doesn't just shine, it's an X-ray pulsar. It's not an ordinary star at all, but a neutron star. Imagine this. A neutron star is so dense that its size might be comparable to a city, but its mass is millions of times greater than that of our sun. It's a collapsed remnant of a massive star that has reached the end of its life, and now it spins at an incredible speed, faster than anything you can even begin to comprehend. This intense rotation causes it to emit powerful beams of X-ray radiation, sweeping through the cosmos like a cosmic lighthouse. These are the objects we call pulsars. The term pulsar comes from their irregular rhythmic pulses of light that appear and disappear with precise timing. As the neutron star spins, it sends out beams of radiation that sweep across space in a regular, predictable manner. To the observer on Earth, it appears as if the light flickers on and off, pulsing like a beacon from across the galaxy. The pulses are so regular, in fact, that they can be measured to an extraordinary degree of accuracy. Scientists use these pulses to map the vast distances of space and even to detect tiny changes in space-time itself. The precision of these objects is awe-inspiring. But as you watch the flickering pulsar in the sky, something doesn't seem right. It doesn't follow the usual pattern. Most pulsars emit a steady, predictable rhythm, but this one seems different. Its pulses aren't uniform. The intervals between the flashes grow shorter and longer in an erratic fashion. Sometimes it seems to disappear entirely, only to flare up once again. It's as if it's fighting against the very nature of what we know about pulsars. What is causing this strange behavior? Could it be that this pulsar is different from all the others? Or could it be part of something even more mysterious? Normally, pulsars are the epitome of predictability, but this one challenges our understanding. It's behaving in ways that simply don't fit the model. It's as if the universe itself is sending us a message, but we haven't quite figured out how to decode it yet. The irregularity of its pulses suggests that there might be an unseen force at work, something influencing this pulsar in a way we cannot yet fully grasp. These unusual pulsars are known as anomalous pulsars. They don't follow the usual patterns of their kind, and scientists have been struggling to figure out why. Some suggest that the pulsar's behavior is the result of an unusually strong magnetic field, one that causes the emission of radiation to fluctuate. Neutron stars are known to have magnetic fields far stronger than anything we experience on Earth. It's possible that this pulsar has an even more extreme magnetic environment, affecting how it pulses and how it emits energy. But there's another possibility. Perhaps the pulsar is in the midst of a powerful interaction with something else, something we can't see. What if this pulsar is orbiting a black hole or interacting with another star in a way that is causing these strange fluctuations in its pulses? The truth is, we just don't know yet. We don't fully understand the nature of these anomalous pulsars, but the evidence suggests that there's something far more complex going on than what we have considered so far. In the depths of space, there are forces at work that we are only beginning to understand. This pulsar is a reminder that the universe is full of mysteries waiting to be uncovered. It's as if this one object in the sky is telling us, look closer, there's more to the universe than you know. The strange behavior of this pulsar may be just the beginning of a much larger mystery. Could it be a signal from a deeper part of the cosmos, something we haven't yet discovered? Or perhaps it's a clue to an even greater phenomenon, something that could reveal a new chapter in the story of the universe itself. Some pulsars aren't just your regular neutron stars. There are certain ones that seem to defy the ordinary laws of nature. They pulsate, yes, but they don't do it in the usual way. These strange pulsars sometimes become much brighter than normal, then fade away entirely, only to flare up again without warning. Their light doesn't follow a consistent pattern. Sometimes they glow with an intensity that far exceeds that of typical pulsars. And at other times, their radiation seems to disappear for reasons we can't explain. These unusual objects are known as anomalous X-ray pulsars. They behave in ways that are so unpredictable, so erratic, that even the most experienced astrophysicists are left scratching their heads. And the mystery deepens when we consider how these pulsars sometimes vanish completely. It's as if they're playing a cosmic game of hide and seek with us, flashing on and off with no rhyme or reason. But why do they behave this way? What is happening inside these strange stars? Could it be that they are revealing something far more mysterious than we can comprehend? To understand the behavior of these anomalous pulsars, we have to dig deeper into their nature. While typical pulsars have a steady, rotating motion, sending out regular beams of radiation, the anomalous ones have an almost unpredictable rhythm. The X-rays they emit aren't steady. They fluctuate in ways that suggest something is distorting their normal pulse. The usual mechanism that powers a pulsar's rhythm, a spinning neutron star emitting radiation from its poles, doesn't seem to explain these strange outbursts. Could these irregular pulses be a sign of something hidden beneath the surface of the pulsar? Maybe the core is behaving differently, or perhaps it's interacting with an external force. The unpredictability of these objects leads many to think that the energy they emit is being influenced by something beyond the typical processes that power a pulsar. Some scientists believe that these anomalous pulsars may be connected to a form of energy that we are only beginning to understand. It's possible that their behavior is linked to a unique type of magnetic field, one far stronger than what we see around regular neutron stars. Neutron stars are known for their immense magnetic fields, but these anomalous pulsars might be experiencing something even more extreme. Perhaps their magnetic fields are twisting and warping in ways that create these unpredictable bursts of radiation. The forces at play in the heart of these stars may be bending the very laws of physics we thought we understood. And then there's the possibility of something far more extreme. What if these pulsars are not simply neutron stars, but rather they're on the cusp of becoming something else entirely? Some astronomers believe that these objects might be in the process of transforming into another type of cosmic entity, something even more mysterious. Could these anomalous pulsars be in the early stages of collapsing into black holes? Or could they be somehow connected to the formation of these invisible, powerful objects? But no matter how we look at it, one thing is clear. These pulsars are anything but ordinary. They aren't just sending out light, they're sending out a message, one that we can't fully decode just yet. They seem to be giving us clues about the nature of the universe, but they're doing it in a way that keeps us guessing. It's almost as if they are teasing us with their mystery, daring us to understand what lies at their core. The fact that they behave in such a strange and unpredictable way makes them both fascinating and terrifying. Scientists want to know what's causing this erratic behavior, but the answers seem to be just out of reach. Could it be that these pulsars are connected to a deeper cosmic force, something we haven't even begun to imagine? Or perhaps they are revealing a truth about the very fabric of space and time itself, one that will shake the foundations of modern physics. What makes these pulsars so perplexing is that they don't just break the rules of how we think stars should behave, they seem to create their own set of rules. And in doing so, they challenge everything we know about the universe. So why are these pulsars acting this way? Are they simply anomalies, or do they hold the key to understanding a new, hidden part of the cosmos? Why do pulsars behave as though they have a mind of their own? It's as if they're alive, pulsating, with a rhythm that is not like anything else in the universe. These pulsations, beautifully precise at first, suddenly shift into something unpredictable. At times, they become incredibly bright, as if the pulsar is flaring with energy, only to vanish just as quickly, disappearing into the void for a few seconds, as though it's hiding something from our view. The light flickers in a way that suggests it's not just a random occurrence. It's as though the pulsar is choosing when to shine, when to be seen, and when to retreat into the darkness. What is causing this strange behavior? Is it possible that the pulsar, is somehow controlling its own light, altering its pulses at will? The idea seems almost too far-fetched, but the reality is that the universe is full of phenomena that seem to defy logic, and these pulsars, these anomalous stars, might be revealing a hidden mechanism, one that we're not yet able to understand fully. One possible explanation lies in the pulsar's incredibly powerful magnetic field. Neutron stars are famous for their magnetic strength, which is millions of times greater than that of Earth's. It's these intense fields that play a key role in shaping the pulsar's radiation. But what if this magnetic field is more than just a passive force? What if it's actively controlling the emission of light, acting as an invisible conductor of energy, guiding the pulsar's radiation in unpredictable ways. Imagine the pulsar as a kind of cosmic conductor, orchestrating the flow of energy like a symphony. When the magnetic field becomes particularly intense, it might momentarily block the pulsar's ability to release its light, causing it to dim or disappear entirely. Perhaps there's a certain threshold of magnetic energy that, when reached, forces the pulsar to pause its rhythmic pulsing as if it needs to gather its strength before it bursts into light again. The field could be bending the very flow of radiation, shaping it in ways that we don't yet fully understand. This would explain why these pulsars seem to behave unpredictably. Their light doesn't follow the regular pattern we expect from most stars. Instead, they seem to pulse according to some hidden rhythm, one that is controlled by the strength and fluctuations of their magnetic fields. In this sense, it's as though the pulsar has its own will, its own desire to control when and how it shines, as though the energy it emits is not solely governed by the rules of physics we know, but by a hidden force within the star itself. But could there be something else going on? Is there more at play than just a magnetic field influencing the light? Some scientists speculate that these pulsars might be interacting with an unseen partner, something that could be affecting their energy output. What if there's another object nearby, a black hole perhaps, or even a second neutron star, that is causing the pulsar to behave in strange ways? If these pulsars are orbiting around another object, the gravitational forces involved could create disruptions in the way the pulsar emits light. This interaction could explain the moments when the pulsar dims or flickers erratically. Another possibility is that the pulsar's own internal structure might be responsible for the unpredictable light patterns. Perhaps the dense core of the star is experiencing fluctuations in its own energy, causing the outer layers to react in unpredictable ways. The intense pressure inside these stars is unlike anything we experience on Earth. It's possible that changes in this internal pressure, or in the way the matter is arranged, could be causing the pulsar to behave in ways that are difficult to anticipate. At the heart of this mystery is the question: what is making these pulsars pulse like this? Why do they sometimes shine so brightly, only to vanish a moment later? And could this strange behavior hold the key to understanding even more about the forces at work in the universe? Perhaps these pulsars are revealing something about the very nature of light, of energy, and of the strange, hidden forces that govern the cosmos. The fact that these pulsars behave in such a complex, erratic way only deepens the mystery. They aren't just simple objects sending out a regular pulse of light. They are active, dynamic entities that seem to be hiding something from us, something we don't yet have the tools to uncover. And so they remain a puzzle, one that beckons us to keep looking, to keep exploring, and to keep searching for the answers that lie hidden in the flickers of light they emit. What if I told you that these strange pulsars might hold a connection to other exotic objects in the universe, objects we still don't fully understand? Imagine for a moment that these pulsars are not just anomalous stars, but clues to something far deeper, something that could completely change our view of the cosmos. Could it be that they are tied to one of the most mysterious and powerful entities in space, supermassive black holes? It might sound far-fetched, but hear me out. These pulsars, with their unpredictable light and unusual behavior, could be the very hints we need to uncover a connection between two of the most fascinating and enigmatic objects in the universe: neutron stars and black holes. These objects are often thought of as separate, distinct entities. Black holes are the invisible giants that devour everything in their path, and neutron stars are the incredibly dense remnants of exploded stars. But what if they're not as separate as we think? What if, in some cosmic way, they are connected, perhaps even interdependent? We already know that black holes and neutron stars are both formed from the collapse of massive stars, but their behaviors couldn't be more different. A neutron star, no matter how dense and powerful, is still a visible object. If we're close enough to it, we can see its X-ray pulses, its bursts of radiation. But a black hole? It's completely invisible, hidden behind the event horizon, its immense gravity bending light and space in such a way that nothing at all, can escape its grasp. Yet, what if these pulsars are the missing link between them? Could it be that some of these anomalous pulsars are not just ordinary neutron stars, but remnants of stars that are on the brink of collapsing into black holes? What if their strange, unpredictable behavior is a sign that they are in the process of undergoing this transformation? Perhaps, as they reach the threshold where gravity begins to overpower all other forces, these pulsars lose their ability to emit regular pulses, flickering unpredictably as they struggle to maintain their identity as neutron stars. This might explain their strange pulses, flaring up at times, fading at others, as if they are caught between two worlds. This idea isn't just speculation. Scientists have long theorized that some neutron stars might eventually collapse into black holes, and the process could be accompanied by a dramatic transformation in their behavior. If these anomalous pulsars are indeed on the verge of becoming black holes, they could be providing us with an early warning sign, a signal that something extraordinary is happening beneath the surface. But there's more. Some of these pulsars could be in the midst of a complex gravitational interaction with a nearby black hole, a process that might be affecting their energy output. The gravitational pull from a black hole could be distorting the pulsar's rotation, causing it to pulse erratically and even steal energy from the pulsar itself. This interaction could lead to the unpredictable bursts of X-rays we observe as the pulsar struggles to maintain its balance while orbiting the massive black hole. And what if there is something even stranger at play? What if these anomalous pulsars aren't just showing us the transformations of a single star into a black hole, but rather a complex cosmic dance between multiple objects? A pulsar orbiting a black hole could behave in ways we can't yet predict. Its pulses might change depending on how it's positioned in relation to the black hole, how close it gets to the event horizon, and how the forces between the two objects are interacting. Could these anomalous pulsars be acting as gateways to even deeper mysteries in the universe? Could they be pointing us toward a new understanding of how black holes and neutron stars are connected, and perhaps even how they influence one another in ways we haven't yet imagined? It's possible that by studying these strange stars, we might unlock secrets about the formation of black holes, the nature of gravity, and the fundamental structure of space-time itself. What if these pulsars aren't just isolated objects, but pieces of a much larger cosmic puzzle, one that spans across galaxies, bridging the gap between the visible and the invisible. Perhaps these objects, caught between the realms of light and shadow, are offering us a glimpse into a universe that is far more connected and intricate than we can see. These anomalous pulsars may be the key to understanding a deeper, more hidden part of the universe. Perhaps they are revealing to us the fundamental truths about the relationships between the most extreme objects in space. And just maybe, they are showing us that the boundaries between neutron stars and black holes are not as rigid as we once thought. Maybe, in the end, they are not two separate entities at all, but two sides of the same cosmic coin. For years, scientists have been trying to decipher the strange behavior of these anomalous pulsars. What causes them to flicker and pulse erratically? Why do they sometimes shine so brightly, only to disappear in the blink of an eye? These questions have puzzled researchers for decades, and there's no shortage of theories attempting to explain their bizarre nature. But despite all the progress we've made in studying these objects, the answers remain elusive. Each new discovery only seems to add more layers to the mystery, pushing scientists to consider even more radical ideas about what's really going on inside these strange stars. One of the leading hypotheses is that these pulsars could be the result of the collision of two neutron stars. When two neutron stars orbit each other closely, they create an intense gravitational interaction, pulling on each other with such force that eventually they spiral inward, their cores merging in a cataclysmic event. This collision releases an enormous amount of energy, producing a brief burst of gamma rays, an event known as a kilonova. Could such a merger be responsible for the erratic pulses observed in some anomalous pulsars? Perhaps the merger creates a situation where the pulsar's rotation becomes unstable, resulting in the irregular flickering of light that we see from Earth. There's also the possibility that these pulsars are interacting with black holes in some way. As we discussed earlier, the gravitational influence of a black hole is immense, and it could easily disrupt the rotation of a nearby neutron star. A pulsar in close orbit around a black hole would experience massive tidal forces, causing its rotation to wobble and potentially triggering unpredictable bursts of energy. It's not just a matter of gravity. It could be that the pulsar is being siphoned of its energy by the black hole, altering the way it emits radiation. This interaction might explain why some pulsars appear to dim and brighten in such erratic ways, as they are caught in a cosmic tug of war between the black hole's gravity and the pulsar's own magnetic field. But some scientists believe that these pulsars might be something even more extraordinary. What if they aren't just the remnants of collapsed stars or the product of cosmic collisions? What if there's something entirely new, something that lies at the intersection of matter and energy in a way we've never seen before? Some researchers have suggested that these anomalous pulsars might be harboring new forms of matter or energy that we haven't yet discovered, possibly even new types of exotic particles or forms of dark energy. Could these pulsars be windows into a new realm of physics, one that goes beyond everything we currently understand about the universe? Imagine for a moment that these pulsars are not simply neutron stars, but complex objects that are somehow connected to the mysterious forces of dark matter or dark energy. Perhaps their irregular pulses are caused by interactions between these invisible forces and the star's dense core? What if these pulsars are trying to tell us that there are entire forms of matter and energy hidden from our detection that are shaping the behavior of the cosmos in ways we cannot yet perceive? Could the study of these strange stars lead us to a new understanding of the universe's most fundamental building blocks? In recent years, astronomers have proposed several more radical theories. One idea is that these anomalous pulsars could be linked to a yet undiscovered class of exotic stars, ones that might exist under conditions far more extreme than we can recreate in laboratories. Some scientists have suggested that these stars might be undergoing a phase of quantum collapse, where the laws of quantum mechanics govern their behavior in ways that defy our current models of stellar evolution. The fluctuating pulses could be the result of interactions between the pulsar's core and some unknown quantum phenomenon, something that bends the normal rules of time and space in unexpected ways. Others have proposed that these pulsars could be affected by something as bizarre as the cosmic strings theorized to exist in the fabric of space-time. These hypothetical one-dimensional defects in space-time could, in theory, cause disturbances in the gravitational fields of objects like pulsars. If a cosmic string passed through or near a pulsar, it could distort the star's rotation and magnetic fields, potentially causing the kind of erratic light patterns we observe. Of course, all of these theories are speculative at this point. We have yet to uncover definitive proof that any of them are true, but what's important is that these unusual pulsars are forcing scientists to think outside the box, to question everything we know about the laws of physics and the nature of the universe. As we continue to study them, we might just stumble upon something far greater than we ever imagined, something that could completely reshape our understanding of the cosmos. And in a way, that's what makes these pulsars so captivating. They are not just celestial objects, they are signals, messages from the farthest reaches of space, beckoning us to explore deeper, to question our assumptions, and to search for new truths. These pulsars may be leading us to answers that we can't even begin to imagine yet, answers that could change the very way we view the universe. Isn't it fascinating that some of these anomalous pulsars behave in ways that seem eerily similar to black holes? They can warp space and time around them, creating distortions in the very fabric of the universe. Their intense gravitational and magnetic fields are so powerful that they don't just affect the light we see, they also distort the space around them, bending and twisting it in ways that challenge our understanding of physics. It's as if these pulsars are more than just neutron stars. They may be hiding something far deeper, something linked to the mysterious forces of quantum mechanics and the elusive phenomena of black holes. Imagine, for a moment, the pulsar's magnetic field. We already know that neutron stars have some of the strongest magnetic fields in the universe. But what if these fields aren't just distorting the radiation they emit? They could also be altering the very space around the pulsar itself. What if the magnetic field is strong enough to cause ripples in space-time, similar to the gravitational waves emitted by colliding black holes? These pulsars could be distorting the fabric of space, bending it in ways that mirror what we see around black holes, creating a localized warping of space-time that could even influence the passage of time itself. Could this mean that these anomalous pulsars are not just emitting radiation, but are also playing with the most fundamental aspects of the universe? What if their strange behavior is a manifestation of quantum effects that we haven't yet fully explored? At the heart of a pulsar, where gravity is so intense and the matter is so dense, quantum mechanics and general relativity collide in a way that we can barely comprehend. These pulsars could be providing us with a glimpse into the strange, uncharted territory where these two forces intersect, and in this realm, the rules of time, space, and matter could be completely different from what we know. This brings us to one of the biggest mysteries in modern physics: the connection between quantum mechanics and general relativity. On one side, we have quantum mechanics, the theory that governs the very small particles, atoms, and the fundamental forces of nature. On the other side, we have general relativity, the theory that explains the behavior of massive objects like planets, stars, and black holes. But despite their successes in their respective domains, these two theories are fundamentally incompatible with one another. They can't both be correct at the same time, and scientists are still searching for a way to reconcile them into a unified theory. Could these anomalous pulsars be giving us a glimpse of this elusive theory of everything? Perhaps they are the key to understanding how quantum mechanics and gravity can coexist in extreme environments, like those found at the core of black holes and neutron stars. After all, pulsars are some of the most extreme objects in the universe, dense, rapidly spinning, and surrounded by intense magnetic and gravitational forces. If any object could reveal the hidden nature of quantum effects, it would be these pulsars. And then there's the possibility that these pulsars are not just revealing quantum effects on a small scale, but are somehow connected to larger, more mysterious phenomena in the universe. Could they be showing us how the extreme conditions inside a black hole might manifest in a more observable form? Some scientists speculate that these pulsars could be shedding light on the nature of singularities, the mysterious points at the center of black holes where space-time collapses into an infinite density. The behavior of these anomalous pulsars might be the first hints we have of what happens inside a black hole, a place where quantum effects and the laws of gravity break down completely. Perhaps the most intriguing idea is that these pulsars could be the key to unlocking a new understanding of the universe itself, one that goes beyond the limits of classical physics. We've always known that black holes and neutron stars are strange, powerful objects. But what if they are more than just fascinating remnants of dying stars? What if they are actual windows into the fabric of reality, places where the most fundamental forces of nature collide and create phenomena that defy our understanding? We might be standing on the edge of an entirely new way of thinking about the universe. As we continue to study these pulsars and their strange behavior, we might uncover new aspects of quantum mechanics and gravity, new clues that could lead us toward a deeper, more unified theory of everything. Perhaps these pulsars are offering us the key to unlocking the deepest mysteries of the cosmos, mysteries that have remained hidden for centuries, waiting for us to discover them. The connection between pulsars, black holes, and quantum mechanics could be the doorway to a new chapter in physics, one that will reveal a deeper understanding of how the universe operates at its most fundamental level. And as we stand on the brink of this discovery, we realize that we are witnessing a cosmic dance of forces far beyond our comprehension, forces that are waiting to be understood. If only we can unravel their secrets. Maybe all these anomalies are just a small piece of a much larger puzzle, one that the cosmos is carefully keeping hidden from us. We find clues, we try to decipher them, but the answers always remain just out of reach. The more we uncover, the more questions arise, as though the universe itself is playing a game of cosmic hide and seek, challenging us to look deeper, to think harder, and to never stop wondering. The search for truth, for understanding, is endless, and that's perhaps the most beautiful part of it all. The universe doesn't reveal its secrets easily. It doesn't simply hand us the answers on a silver platter. Instead, it invites us into a dance of discovery, urging us to keep searching, keep asking, and keep questioning. And every time we feel like we're getting closer to the truth, a new mystery emerges, just as perplexing and awe inspiring as the last. It's an infinite cycle of revelation and wonder, and no matter how many answers we uncover, the cosmos always has something more to show us. In many ways, the most profound beauty of the universe lies in this very mystery. We are surrounded by wonders that we still can't fully comprehend, stars that pulse and flicker in ways we don't understand, black holes that bend the very fabric of space, and neutron stars whose behavior defies explanation. These phenomena are not just objects in the sky, they are symbols of everything that remains unknown, everything that still beckons us to learn, to explore, to push the boundaries of human knowledge. Perhaps that's the greatest gift of the cosmos, its endless capacity for wonder. It never stops challenging us, never stops surprising us, and always keeps us on our toes. Every mystery solved only leads to another, more complex enigma. And even though the answers we seek may forever be just beyond the horizon, the pursuit itself is what drives us forward. It's what pushes us to build bigger telescopes, develop more advanced theories, and ask deeper questions. It's what makes us dream of the stars and reach out into the unknown, knowing that the universe will always have something new to teach us. And maybe, just maybe, one day you'll be the one to unlock the next great secret of the cosmos. Perhaps you'll be the one who finally cracks the mystery of these anomalous pulsars, or who uncovers the connection between black holes and quantum mechanics, or who discovers an entirely new form of energy that has yet to be imagined. Whatever it is, remember that the universe is vast, its mysteries are infinite, and the search for answers will never end. Until then, keep looking up, keep wondering, and keep seeking. For the universe, with all its beauty and mystery, will always be there, waiting to share its secrets with those brave enough to ask the questions.